Okay, so we have a definition here of how to show two sets are equal to each other. This is a big deal. To show two sets are equal to each other, if and only if means you have to go both ways, right? Two sets are equal to each other if A is a subset of B and B is a subset of A. Okay, so that's a true thing. Oops, sorry, I should have done another line on this one. Another definition. There we go, red. Okay, A and B are disjoint if and only if the intersection between A and B is the null set. So that would mean A and B have to look like this, right? There's nothing in common between them. So that's called disjoint. So that's a picture of disjoint. Okay. So these sets, let me use a different color here. So then there's a new definition. So I have many sets, n sets. They're called mutually disjoint. If I take any ij all the way up through n, I take the intersection between any of them, and it's the null set. So if I was to take a picture of this, so here would be A1, here would be A2, here would be A3, right? So all of the sets have nothing in common, right? A6, and let's call this A7. So all of these 7 sets, right, it's a finite number, all of these 7 sets have nothing in common. They're called mutually disjoint. All right, so A union B means that X is in A or X is in B, right? It could be in either one of them, A or B. A intersect B means that X is in A and X is in B. What's in common between the two? Okay, so B minus A. All right, so perhaps I'll just draw a picture. So A union B, if this was A and this was B, so A union B would be anything that's in A or B, right? This one here, intersect, if this is A and this is B, the intersection would be just what's in common. Okay, so this one's a little bit different. So this is called the relative complement. So here's, they could be separate, but I'm just going to put them together like this. So B take away A. B take away A means X is in B and X is not in A. X is in B and not in A. So that would be this. So this is called the relative complement. A complement means that it's not in A. So if here's A, and here's the rest of the world, right? A complement would be everything that's not in A. Good? Okay. So let's move on and do some examples. So what do I have here? I've got some number lines, and I want us to be able to put them together. So let's draw a picture of what A looks like. So A is between -3 and 0. And it includes the endpoints, right? There's A. Okay, so let's look at B. So B, and I'm just going to draw them underneath each other so I can compare them, right? So here's 1 and 4. So I include 1 and not 4, and it's things in between. And then look what C is. So that's 1. C goes from 3 to 9. Include 3, but don't include 9. Okay, so A intersect C. A intersect C. So what's in common between those two? -3 to 0 and 3 to 9. Well, that's the null set, right? There's nothing in common between those two. Okay, so B complement. Things that are not in B. Okay, so how am I going to say that? So I want to say I can come all the way up to -infinity, go up to 1, don't include 1 because it's included there, or start at 4 and go up to infinity. And always the round parentheses around infinity, you know that, right? Okay, A union B, A or B, so start at -3, go to 0, and there's nothing in common between A and B, so you just have to just state what they are, right? A or B. Okay. A union B complement. What? Okay, everything that's not here, right? So that means I want to go -infinity up to -3. or, and then I've got between 0 and 1, or I can start at 4 and go off to infinity. Okay, A complement and B complement. Okay, so let's write down what A complement would be. A complement would be everything up to -3, and then anything after 0. That would be A complement, right? Then let's look at B complement. So B complement would be anything up to 1, don't include 1, so up to here, and then include 4 and go out further, right? Okay, so put these two together. So I got up to -3, -3 is back here, go up to 1, oh wait a minute, there's 1 is over here, and then it continues going. Oh, I think it's all reals.